going to discuss a question related to Archimedes principle. So we will go directly to the question. So the question is, a 3 centimeter thick layer of oil with density rho naught 800 kilograms per cubic meter is floating above water that has density rho w 1000 kilograms per cubic meter. So there's a diagram, so I will draw the diagram. So we have a beaker. So the beaker contains a layer of oil. So the layer of oil thickness is given as 3 centimeters. And the density of oil is given as 800. So we will say this is rho naught. That will be 800 kilograms per cubic meter. And this is water. It is labeled as rho w. And the density of water is given as 1000 kg m-3. Right? Okay. Now it is said that a solid cylinder is floating so that 1/3 is in water, 1/3 is in oil, and 1/3 is in air. So the solid cylinder which is floating like this is a uniform cylinder, right? So it is floating in both these liquids. So 1/3 of the total height is immersed in oil, 1/3 in water, and 1/3 in air. So that means all these three lengths must be same. That means this length also 3 centimeters. This length also must be 3 centimeters. So this is a solid cylinder of total 9 centimeters height. Okay. The first part data is done. The second part data. Additional oil is added until the cylinder is floating only in oil. What fraction of the cylinder is in the oil? So now we are doing is, now we are gently putting some oil into the system. So what happens is, it is said that now the cylinder will move completely into the oil layer. So the top layer is the oil because density of oil is lesser than density of water. So now cylinder is now like this. Now it is fully in the oil layer, no any small portion in water, all the parts in oil now, right? Now we will assume the immersed part in oil as x. Then the part in air is 9 minus x. So we have all the height details, right? And this is a uniform cylinder. So what we can take is, we will say the cross-sectional area of this cylinder as capital A. That is the cross-sectional area. The question is, what fraction of the cylinder is in oil? So fraction of the cylinder in oil. So we know that total height of the cylinder is 9 centimeters and the amount in oil is x centimeters. So the fraction, we can write fraction in oil is simply x divided by 9. So if you can find x, then you can find the fraction in oil, right? So now we will go into the question. So as soon as you see this one, it is very clear to us that this system is in equilibrium. It is given like that. So if this system is in equilibrium, it should be force balanced. So first thing that we should do is to mark all the forces acting on the object, because the cylinder is in equilibrium. So you should mark the forces on the cylinder. So we will mark. So this has a weight, therefore definitely the weight should be marked. So you will see weight is mg, right? And it is immersed in a liquid. So we know that when an object is immersed in liquid, according to the principle of Archimedes, some of the water is displaced, some of the volume of the liquid is displaced, and as a result upthrust is generated. So we will say upthrust acting on the object by water is UW, and it is again immersed in oil. So oil is also giving upthrust. So we will say it is U naught, U oil. And when you come to here, the total weight, there's no change in the weight of the cylinder. Here it is mg, here also it is mg. Now you can see that nothing is immersing in water. Total part is immersed in oil. Therefore, upthrust is only coming from the oil. So we will note that one as U naught dash. It is U naught dash. Right. Now we have marked all the forces acting on the cylinder. Now we can go for the simplifications. Right. So this is, as the system is in equilibrium, you can first take the equilibrium of the first scenario. So we will mark. So what happens is that as this is in equilibrium, we can consider vertical equilibrium, and it will give you U naught plus UW should be equal to mg. Right? Here if you take the equilibrium, you can write U naught dash is equal to mg. This is the force balance for both the scenarios. So we know that from Archimedes principle that upthrust can be written as V rho g. So here V means the volume immersed in the liquid, rho means the density of the liquid, g the gravitational acceleration. So we have all the required data, so you can write down the expression. So U naught means amount immersed in oil. That is easily we can write as 3 into A multiplied by the density. Now volume is done, cross sectional area into height means the volume. Now density of the liquid is 800, and the gravitational acceleration I will put g. You can put 10, but we will just put g. We will see y plus uw. Now amount immersed in water, that is 3 times A multiplied by the density, that is 1000, and the gravitational acceleration is g, and this should be equal to weight of the object. Now you can see here each and every term has g, right? So you can cancel out. Oh, before that we will substitute here also. So here the amount immersed in oil is, the height is x times v, that is the volume of volume immersed in oil, times the density of oil, and g, that is equal to mg. Because in here also the same cylinder is in equilibrium, so there is no change in the weight. So you can see clearly that this one is also equal to mg, this part is also equal to mg. Therefore these two parts must be equal. So now you can take one single expression, right? So before writing down that expression, you can do one simplification. That is, here you have g, here you have g. You can cancel out. Here also you have g, g, g. You can cancel out. Now you can substitute you can equal both expressions. So here we can get 3a into 800 plus 3a into 1000 equals xa into 800. Now you can go for the further simplifications. This is very simple simplification. 0, 0 cancelling out, 0, 0 cancelling out, 0, 0 cancelling out. Here we have 24 and a. You can cancel out a also. It is common for all three terms. Now you have 8 times 3 24 plus 3 times 10 30, and you have 8x. Each and every term can be divided into 2 again. So this is 12, 15, and this one is 4. So finally you can get x is equal to 27 over 4. So this is the value, this is in centimeters. So the total height immersed in oil is 27 over 4 centimeters. So what we need is the fraction, so you can directly substitute here. So now x is 27 divided by 4 multiplied by 1 over 9. So here you can simplify easily. That will be 3 over 4. So this is the final answer. Right. Hope this is very much clear to you. So important things to remember about this question. So you have to use Archimedes principle. So Archimedes equation you have to use here. That is U equals V rho G. So when substituting this equation, please keep in mind V means the immersed volume or the volume inside that liquid, only in the considering liquid, because if you consider here, when you are writing the upthrust by water, you have only to substitute the volume immersed in water, not the any other volumes. So when you are writing volume upthrust of oil, you have to substitute volume immersed in only oil. So keep that in mind. Rho means the density of the liquid, not the density of the object. In some questions, we are given both the data. So remember, you have to put the density of liquid, not the density of the object. And G is the gravitational acceleration. So because that is very important, because we know from the derivation of this equation, the gravity plays a very important role. If there is no gravity, if G is 0, there will be no any upthrust. Okay. So we will meet some in other video how we derive this Archimedes principle. So hope you understand this question very well. So please practice these questions and get ready for your examinations. So if you are liking this video, thank you very much, and thank you very much for joining with me to share knowledge. Thank you.